So we'll begin our Chapter 4 review by talking about what a process is. And so what is a process? Now, traditionally, chemical and biomedical engineers deal with processes that involve chemicals or involve some type of chemistry. Specifically, we deal with operations that cause a physical or chemical change to a substance or a mixture of substances. To a substance or mixture of substances. All right. And so in MEB1, you saw many different examples of various types of processes. One of the most common ones that you could probably remember is the combustion reactor, where you reacted oxygen with either methane, ethane, or some sort of hydrocarbon, and the product of that reaction was carbon dioxide and water. And so typically these combustion reactors are very large unit operations. But processes don't necessarily have to be big. They could be something that's much smaller. For example, some of you may have made coffee this morning. Right? And making coffee itself is actually a process, right? You're basically extracting, the caffeine and the coffee liquid from your coffee beans into your coffee cup. And so by the definition that we wrote up there, making coffee is a process, right? And there are many other examples of processes, all right? And so, these examples deal with, causing some sort of physical or chemical change to a substance. But nowadays, now that we're in the age of big data, we could be a little bit more general with our definition of what a process is. And so nowadays, the way we define a process is just something that converts inputs into outputs, right? And so those inputs, they can be chemical substances or materials, but they don't necessarily have to be, right? Right? You could deal with a process that just makes parts, for instance, if you were building a car. Or you could even be more abstract, and you could just deal with a process that deals with strictly data, right? In any case, a process is just something that converts an input into some sort of output. Right? And so there's many different types of processes out there, and you could distinguish them based on various factors. Right? One of the most common ways to distinguish between different types of processes, so different types of processes. Yeah, one of the most common ways you could distinguish between them is by looking at their time dependence. Okay? All right, and so with that, one type of process, or one type of word we could use to describe a process, is a transient process. And so here, what we have is some sort of process variable, y. Here, the process variable would change as a function of time. It would not be constant. Okay? Mathematically, we could describe it like this, where the derivative of y with respect to time, or t, that derivative is not equal to 0. All right? And so y here is just some process variable. It could be mass, could be moles, could be temperature, or even amounts of data, right? Regardless of what it is, in a transient process, the value of y would not be constant over time. The converse of this is a steady state process. And so in this type of process, y is constant over all time. And so its derivative, dy dt, is going to be equal to 0. We could also classify processes based on whether or not they have input or output streams. Right? And so if we go by these factors, one type of process that we could describe is the batch process. Right? And so in a batch process, what happens is you have some sort of feed that's charged at the beginning. Right? And then, when that feed is within the process, something happens to it. And then after some time, you end up with a product that's removed at the end. Okay? And so with the batch process, your input and output streams never cross the system boundaries over the period that that process is occurring. And so no material crosses system boundary. Okay? Or during process. During process. And so for these batch type processes, they're typically also transient processes where, the amount of material of some species is continuously changing over time. Okay? And so that's a batch process. The opposite of that is going to be a continuous process. And so here, in continuous processes, you do have input and output streams. Right? And they cross the system boundaries. System boundaries. With a continuous process, they can be steady state, so dy, but they could also be unsteady state as well. So it just depends on the context of the process. So I've talked about the different ways that you could distinguish between processes based on math. But now I just want to give you some concrete examples of different processes. And so in the photo at the top here are various fermentation tanks. And so these are the types of unit operations that are used in beer brewing, for example. And so what happens here is you fill this fermentation tank with some sort of sugary water solution, and then you also add yeast to it, and then you close off the tank. Over a period of weeks and perhaps even months, the yeast then converts that sugar into alcohol. After some set period of time, the tank is then opened, or the product is released from the valve at the bottom that you see there. Right? Coincidentally, these fermentation tanks are also very similar to the types of batch reactors that are used to synthesize the gene therapeutics that are used in the COVID vaccine. And so these batch reactors can be very large. But batch processes don't need to be really big. For example, in the photo at the bottom is another type of batch process, but one that's much smaller scale. Specifically, it involves cooking. The chef here is just frying some donuts on a frying pan. And so batch processes can be very big, and they could also be very small and, something commonplace. To show you an example of a continuous process, in the photo that you have here, this is a photo of a reverse osmosis membrane stack that's used to convert salt water into fresh water that you could drink. And so what happens here, in each one of these membrane stacks, on the right-hand side, you feed in a freshwater solution, or not a freshwater solution, a saltwater solution, all right? And as the salt water passes through the stack, it then permeates through the membranes towards the center of the cylinder. The water itself can pass through the membrane very easily, but the salt cannot. And so because of this, on the left-hand side of the membrane stack, what you end up with is two different streams, a very fresh water stream and also a very salty water stream. Okay? Another type of continuous process is one that you may have seen if you've ever visited a Krispy Kreme and looked at their conveyor belt donut system. And so in contrast to frying a donut in a frying pan, with this conveyor belt setup, this allows Krispy Kreme to continuously produce donuts all throughout the day. And so with these examples, what I want to show you is that there's many different types of processes out in the world, and they come in all different shapes and sizes.